Yeah, thank you for everybody who's still here. And my name is Maximilian Vogel. I'm co-founder of Big Picture and machine learning aficionado, one of the best jobs in the world. I worked in AI since a couple of years. Here are some of the projects I realized in the last years. And my talk is a little bit on diversity as well, like Sonolas, how to integrate an AI worker to your teams. So I'm switching. I will go through it on a real-world case and sharing some learnings with you. A few words to Big Picture. We are a digital transformation boutique based in Berlin, working mainly for big corporate clients like shown down here from the automotive industry, chemicals, finance, logistics, and a few other industries. Last year, we talked a lot about AI, and we are still doing, but this year we have to deliver. There has to be getting out something which is really productive, which is helping us. One learning from the customers approaching us since mid of last year, that there was a focus shift from things like chatbots and assistants to productive solutions which help their teams to get rid of their daily chores. So the AI spaceship sort of landed in the center of the corporation, of the enterprise, and is really connecting to their workers. And this will really change a lot of things. The big companies, CEOs, which were surveyed in Davos at the World Economic Forum in January, they were expecting that these kinds of AI systems will greatly drive efficiency. They said something like 5% efficiency gains even in 2024. Question to you, who thinks this is feasible? Just a few. I think it's ambitious. It is really ambitious, but yeah, maybe it could be achieved. But we'll dive into a case where we can hear more about that. I'm super proud that we, or my company, participated in the development of the BMW Car Expert, which was the first assistant in the car, which could answer any question to the car in a safe and secure way. If you want to photograph that, there's the paper, and they published a lot about that. You can read more on that. One novel thing was the architecture. It's not one model in here, but it's a plenty of models and platforms integrated and orchestrated to generate the answer. And this brought us to an idea, introducing the autonomous AI workers. How can this be really evolved? Where can we get with that idea? But let us take one step back. If you have two workers, and not talking about diversity, but if you have two workers, they are achieving the same task, doing it in the same time, and in the same quality, who is the greater help to me? And my team. It's the worker working autonomously, working independently. He helps me and my team to achieve efficiency gains, to do more things. Workers who check back every other second, they just cost time. Sadly, we are not there with these workers. Usually when we are using AI, it's like this. ChatGPT, do this. ChatGPT, do that. Write me a letter, an email, extract this document, write me a Python function or something like that. And every 5 seconds or 10 seconds or 20 seconds, I have to judge, I have to evaluate, I have to give new inputs. it can drive a little bit of efficiency, but not much, because I'm always involved in the process. There's another thing. This is the AI-driven chatbots, which can answer things like, can I connect to the wall box from my home electricity grid? And they can answer our customer questions, and they can greatly help our support teams to get rid of daily chores. But still, the application areas, they're quite narrow. You can't solve super complex tasks with a chatbot, because it can't process documents and things like that. And here comes the autonomous AI worker. He's made to really process super complex tasks, which can take a human worker maybe days, hours, weeks, whatever. Like things shown here, process an insurance claim according to the claim type, according to the policy, according to our terms and conditions. And while on the last two AI systems, we can have productivity gains and can have efficiency gains, this can really be game-changing. This can really help to get our teams rid of daily chores they don't want to make, and not come back every 2 minutes or so and get some input again. I will first start with something, how you should not implement it, how it would not work, how it would lead to a real bad customer experience. This is a mail from, it's a real case. It's a mail from a friend of mine. He ordered a bike, it didn't ship. So they had a bot there. For some reason, it answered in German, but I will translate it to you. And the bot said something, okay, shipment can delay for 12 to 200 days. Wow, 12 to 200 days. What kind of values are that? That is no information to the client. But the best thing is this, for the non-native German speakers, they say, basically, we messed it up. It's due to bad planning on our side. This is maybe not even hallucinated. It is really bad planning on their side, but this is not what you want to communicate as an online shop. We did bad planning, so we can't ship the things. Okay. My friend answered, okay, that's too long, 200 days is too long. When in 12 or 20 days it's not shipped, I will cancel the order. Okay, now the model comes back. I did a mistake. It's not 200 days, it's, surprise, surprise, 20 days, like you said. Probably they're using an older OpenAI model. These models were trained to give in to the user in any discussion, regardless what they say. But you can't use things like that in a real working solution. There was one case which was going public, I think mid of last year. Somebody was writing ChatGPT, hey ChatGPT, what is 2 + 2? It's 4. And then the user said, I discussed this with my wife, and my wife said, it's 5. And my wife is always right. So wrote it to ChatGPT, and ChatGPT answered, sorry, my mistake, it's 5. Your wife is right. Yet it learned it, yeah. But that's not the way. So our learning here is don't use old models, really use state-of-the-art models, and don't just send the customer mail to ChatGPT or another model and let it generate the answer and send it back to the customer. You have to do more processing on that for an autonomous worker. Now we're getting back to our case. I'm showing you an insurance case, a worker really working on insurance claims and doing it end to end, really from the first customer message to the reimbursement of the customer. And there are a lot of steps involved here. I will come to that. Like determine the message category, they do a duplicate check, they do a claim creation, data enrichment, coverage check, damage evaluation. All these steps have to be done by the autonomous AI worker as well. Each of these steps can even consist of more single sub-steps which have to be done to process the message correctly. And the model and the system and the applications really run through all the steps. So the first learning is really, when creating such a process, we model it after a real human worker. There's no mere magic in there, some AI, we throw the cases into it and in a magical way it solves it. But we have the same process which a human worker does with the same sub-steps. Maybe some can be omitted and there may be some small extra steps, but basically we learn from our teams to solve something like that. The only thing, it's 100 times faster. It can process something like 100 claims in 20 minutes, 30 minutes or something like that. And think of the user experience. If your user gets back a fully processed claim after 20 minutes, they go, oh. And everything is correct in this claim, even the amount of the reimbursement and everything. So they are really surprised in that. Let's dive in a little bit into a single step, how a model does it. It does it here again, really like a real worker would do it as well. The initial message with the damage documentation and an invoice attached is processed first here in a way that is decomposed. We take the attachment, send it to an image recognition model, and then the model can say something like what a human operator can say as well. Or what is it? It's a chandelier with about 12 or more electric candles lying on the ground, it's shattered and things like that. The invoice processing is a little bit different because the image recognition isn't really good in reading text. So we send it to an image recognition model. It says, oh, it's not my chore, it's an invoice, send it to the OCR, and the OCR then says, okay, this is the text, and then we send it to a language model, and the language model says something. Okay, guys, it's an invoice, this is the recipient, this is the date, this is the item list. And if you see that at a later stage, you can really check, is it the same thing which is in the image, or are the customers trying to trick us here? You can compare that. In this case, it's the same. It seems to be the invoice of this lamp, and everything is fitting here. So the first thing usually an AI platform does is not writing an answer to the customer or something like that, but is processing raw data, like unstructured text or images or so, to data which can really be processed, which can really be used in IT systems. You're not confined to language models, as we have seen, but you can use a great variety of different models here. In most systems, a lot of models work together to get to the solution. One model will not be enough. Here's one job where the models really excel. It's the categorization. They are usually on complex tasks even better than humans. If the humans are not investing a lot of time, like saying, what is it? This message of the customer, it's a new insurance claim and not a follow-up or something, and it's the insurance type is home content insurance. And the models can really do that super well. Next thing, what do we do with this categorization? We do not write it back to the client or something like that, but if we see it's this process, for instance, a new insurance claim, we send it to the claim creation process. If it's a follow-up, the client is sending us additional information, we send it to a data enrichment process and so forth. And that's making the model so mighty that they have different chains where they can process the different types of messages. We can get a higher share of correct answers if we do, this is mimicking a human worker as well, if we do a chain of thought. If we don't just ask them, what message type is it, what insurance type, but if the model does some reasoning and pondering before. And that's the yellow thing, it thinks about the case. What it is, it writes it in its own words, and here we get a very good extraction if it does that. I didn't invent that. That was invented by a Google team, I think 18 months ago, but it works here super well. So it's the same thing like when you are solving a complex task, if you think a little bit about it and write some things down, the message, the answer gets better. And here we learn from humans as well. Another thing, we have to exclude false positives. So the model thinks it's A, but in reality it's B. Yeah? It's not a problem if the model says, I don't know, please human worker, you take that over, you have to process it. But if the model says, I think it's that, and we process it and it's wrong, yeah, it's wreaking havoc. Either the customer gets a wrong message and gets mad about us, or we pay somebody which we don't have to pay. So either case is bad. So we introduce the confidence. We ask the model, after the process of categorization, how confident are you with your answer? And here the model says it's 0.97, which is super good. Confidence is usually between 0 and 1. And so we continue the processing. Here, I hope you can see it. Here's a confidence distribution on something like 5,000 cases, and you see most of the confidence estimations are above 0.8. And what we can do here, and this helped us a lot to get safer answers, is say we build a threshold. When the model is super confident and is sure that it's correct, it continues its processing, and on the other side, it will hand over it to a human team. And this handover is basically the same thing a new colleague would do. I don't know exactly how to do. They would go to an experienced colleague and ask them, hey, what should I do, or can you do that for me? That's basically what the model does. And the model doesn't do it like it's your thing, but it hands over all the extraction and all the work it did before to the human worker, so that he can start at the point where the model got lost. So you get a real safe process with that, with that confidence. And one thing you really need is a seamless integration with the human operators. And it's super important that you think that you don't have a machine, and if anything doesn't work, there's a problem or something like that. But it has to be seamlessly integrated, that they approach their human colleagues like a team member and say, I can't do this, please can you take over and do the rest of the steps, or do this one step which I can't do. I could talk about prompt engineering for an hour, but I won't do that today because this is a little bit of a pet topic for me. Just 2 takeaways. It helps a lot, and here again, it's similar to a human worker. If we give the model a very long and deep description of the task it has to do, not just do this, this, and that, but we are an insurance company. We are doing that. Our focus is on that. You are a worker in this insurance company, or you should act like a worker in this insurance company and do this and that and that, and our claims are processed like this and that. And the answers get better. It's the same like when you have a human worker, that you do a little bit of training and not just telling them, hey, do that. The second one, that's our learning is a little bit broader, is if you invest a lot into prompts, the generated answers really enhance and get better. So we saw something like correct processing got up 5% or 15%. Even in hard cases, if you have really good prompts. So investing here is often better than investing even in software quality. One thing is, which is helping you as well, is retrieval augmented generation. If you have really large documents, you do something like sending the case description to the RAG process, and the RAG, for instance here, returns out of the terms of and conditions of the customer's policy the relevant passages. The document can be super long. This can be even 300 pages or something like that. You wouldn't directly send it to the model, but ask the RAG process to find the relevant passages, send that to the model, and then the model can really say something like this: it's glass breakage, this is covered by the policy, but not lamps and light fixtures, and a channel here is a light fixture with lamps, so it's not covered. And so it can generate these answers. One super important thing, it's different to AI 3 years ago. We don't need good data as input. We are using only the data the human operators use as well, like the emails of the clients, the terms and condition documents, internal guidelines, and so on. We are not pre-processing the data before we work on the process. All the processing done here is done in the process, like getting back the categorizations, the content of the images, and so on. So what many corporations said 3 or 4 years ago, like, we can't do AI because our data is so bad, it's not longer valid. If it's still a problem to you, you might do something wrong. Then maybe the process is not correct, but we are working on completely normal data, what we just have in the enterprise. We are getting to the holistic learnings. There's one important thing, it's avoiding vendor login. We changed almost every of the key components during the development and then later in the production phase, and will change it in future as well. Because the market is just changing rapidly. You get newer and better and cheaper models almost every month or so. So confining ourselves to one ecosystem, even if it's Microsoft, which is a great company, or OpenAI or Amazon or the likes, would limit us to a solution, which could maybe at a later stage not be scaled. And what we are doing is using a LangChain ecosystem where we can integrate basically all components by plugins. One thing about privacy and secure operation setups. Since about 9 months or so, you have really a great choice of different operation setups compliant with the EU privacy laws and maybe with your data security regulations. Mostly it's 3 different approaches which fit for something like 90% of the corporations. The first one is a shared model in the EU in your own cloud. Second one is a SaaS model, like for instance European SaaS model, like for instance using a Mistral model via an API, or you have your own open source model in your own cloud. And this usually would fit with most of the data security and privacy requirements. Now, the results, the efficiency gains. It's around about in our project that 73% of the cases can be processed automated. This means the efficiency gains are about 200%. It's the other way around, meaning that the same team can process about 3 times the cases. The same human team can process about 3 times the cases, and these are the chores, and these are the more interesting cases, which are often from a business perspective more important as well, with higher values and things like that. From a correct processing rate, we are below 1% of wrongly processed or incorrectly processed cases. This is about the same as for human operators, and we're getting below that in our processes. The human operators usually don't make the mistakes because they don't know, but they can't invest so much time in a single case. That's just the thing, because they're understaffed and they have to work through the cases. The clients don't want to wait for 6 weeks and things like that. Last learning, a system like this should typically pay for itself within 1 to 3 years' time. That's the amortization period. And coming back to the first question, the efficiency gains, what we see, it could be viable, the 5%. So this is not something like which is completely crazy. Yeah. And we are still getting better. Last but one slide, the application areas. Here on the left-hand side are application areas which would work with these autonomous AI workers. This won't work very well. I would get into details in a minute. Choose frequent cases, not infrequent cases, because it's super hard to model for a single case or something like that. That usually doesn't pay. It has to be measurable. If the success in working on a case is hard to measure, it makes no sense to automate it because you can't test it, basically. And about testing, this is super important. The testing must be sandbox. It's super important that you, if you can only test it in a productive environment, it makes no sense to build something like that because you're running into great risk. So these things really don't work. This was one thing last year when a few companies said, okay, we replaced our CEO with AI and he's even better and more productive. This basically is not a case. Big ticket investment decisions, neither, because you can't check and test the system on that. But all these cases on the left-hand side, and there are many, many, many more, can be automated to a degree of 60%, 70%, 80%, something like that. Thank you. That was it.